Hello everyone, we are still in week 1 of the first quarter of this school year. So this time we're going to have a special type of sequence. So get ready for this new learning. We will use module 1 about sequence, but we will focus on arithmetic sequence. At the end of this session, you will be able to define as an arithmetic sequence, recognize arithmetic sequences, and solve for the nth term of an arithmetic sequence. The sequence 1, 4, 7, and 10. 1 is the first term, 4 is the second term, 7 is the third term, and 10 is the fourth term. So we have 4 terms in the given sequence. Notice that the difference between the two consecutive terms is positive 3. So when we say difference between two consecutive terms, that means the gap between them. So the gap between 1 and 4 is positive 3. The gap between 4 and 7 is positive 3. The gap between 7 and 10 is positive 3. And this positive 3 is called the common difference. And once a sequence has a common difference, you call it as arithmetic sequence. We can use the common difference to get the next term of an arithmetic sequence. So for this one, 10 plus 3, you will get the next term as 13. Okay, another example here is the sequence 2, 5, 8, 11, and 14. If you will notice, the difference between two consecutive terms in the given sequence is the same, and that is positive 3 also. By definition, we know or we can define that arithmetic sequence is a sequence of numbers such that the difference of any two successive members of the sequence is a constant. So for this one, we said this is an arithmetic sequence since the difference between two successive terms or members of the sequence is the same. And that is called the common difference denoted by letter D, small letter D. So make sure that before you say that a sequence is arithmetic, you will be able to determine what is the difference and if that is common to all the consecutive terms in the sequence. To find the common difference, you simply subtract any term from one that follows it. So for example, you subtract 2 from 5. So that is 5 minus 2, and that is 3. Subtract 5 from 8. So 8 minus 5 is 3. Subtract 8 to 11. So that's 11 minus 8 is 3, and so on. So with that, we know that the next term here is 17, correct? In other words, an arithmetic sequence is a numerical pattern that increases or decreases at a constant rate or value. That is called a common difference. Identify if the given sequence is arithmetic or not. If arithmetic, determine the common difference. 3, 7, 11, 15, and so on. Is it arithmetic or not? So determine first the difference between two consecutive terms. So 15 minus 11, 11 minus 7, 7 minus 3. Is the difference the same? Yes, and that is positive 4. Therefore, this sequence is an arithmetic sequence. Okay, next we have negative 2, negative 6, negative 10, negative 14, and so on. So first, try to get the difference. So negative 14 minus negative 10, negative 10 minus negative 6, and negative 6 minus negative 2. So recall the operations on integers. That would mean subtracting integers, you have to change the sign of the subtrahend and proceed to addition. So that would mean negative 14 plus 10 is positive. Negative 14 plus 10 is negative 4. And negative 10 plus 6 is negative 4. Negative 6 plus, negative 6 minus negative 2 means negative 6 plus 2, and that is negative 4. So that is an arithmetic sequence. Another example is square root of 3, 3 square root of 3, 5 square root of 3, 7 square root of 3, and so on. So try to get the difference. 7 square root of 3 minus 5 square root of 3 is 2 square root of 3. 5 square root of 3 minus 3 square root of 3 is 2 square root of 3 again. And 3 square root of 3 minus 3 square root of 3 is again 2 square root of 3. Therefore, our common difference is 2 square root of 3. That makes it arithmetic sequence. This one. 16, 12, 9, 8, 4, 2, and so on. So try to get the difference. 2 minus 4 is negative 2. 4 minus 8 is negative 4. So they're not the same. Therefore, this is not arithmetic sequence. Okay, next we have negative 19, negative 8, 3, 14, 25, and so on. So the same thing, we will try to get the difference. If they are the same, then it is our arithmetic sequence. If not, then it's not an arithmetic sequence. So 25 minus 14 is 11. 14 minus 3 is 11. 3 minus negative 8 means 3 plus 8. That is 11. Negative 8 minus negative 19. So that is negative 8 plus 19. And that is still 11. Therefore, we have a common difference that is 11. So that makes it an arithmetic sequence. Next, we have 1/2, 1/4, 1/8, 1/16, and so on. Is it an arithmetic sequence or not? No, it's not an arithmetic sequence because you cannot have the common difference from 1/16 minus 1/8, 1/8 minus 1/4, 1/4 minus 1/2. Okay? Next. 1/3, 2/3, 1, 4/3, and 5/3, then so on. Is it an arithmetic sequence or not? Correct. It is an arithmetic sequence, and the common difference is 1/3. Is that clear? Next. Let's try to have some examples to determine the first term and the common difference of an arithmetic sequence. So for the sequence 4, 9, 14, 19, 24, what is the common difference and what is the first term? So the first term here is 4. And the common difference, can get the common difference by having 24 minus 19, 19 minus 14, 14 minus 9, 9 minus 4. So that is 5. Okay, they are all the same. Next. 34, 27, 20, 13, 6, negative 1, negative 8, and so on. So what is the first term? Correct, it's 34. And the common difference is negative 7. Next. Be careful. Always check to make sure that the difference is the same between each term. So at least 2 pairs that you will try. Okay. The first term of an arithmetic sequence is denoted by a sub 1. And we add the common difference represented by small letter d to get the next term of an arithmetic sequence. Observe that there is a pattern that we will get, and therefore, there is a formula that we can use to give us any term that we need without actually listing the whole sequence. Interesting? Let's see. 3, 7, 11, 14, and so on is an example of an arithmetic sequence. The first term is 3 and the common difference is 4. Observe that from the first term going to the second term, we simply add the common difference. That makes it 7. On the third term, we simply have the first term plus 2 of the common difference. So that makes it a sub 1 plus 2d, which is 3 plus 2 times 4 for your d is equal to 11. To get the fourth term, from the first term, you add 3 common difference. So that is a sub 1 plus 3 of the common difference. That makes it 15. Okay, for example, given that a sub 1 is equal to 6 and common difference is 9, what is the second, the third, and the fourth term? So from the first term, let's look for the second term. So we know that that will be 15 since we only add the common difference from the first term. If you will relate that to the first term, a sub 1 plus d will be your a sub 2. To get the second term, from 15, you simply add 9. And this 15 can be substituted as a sub 2. Your a sub 2 is equivalent to a sub 1 plus d. Therefore, your a sub 3 is simply a sub 1 plus 2d. Your a sub 3 is 24. Then, to look for a sub 4, simply add 9 to it. And that gives you 33. Working backward, so that's 24 plus 9. And that 24 is actually the third term. And this third term is actually equal to the a sub 1 plus 2d, this one. Therefore, if you will add this common difference, then a sub 1 plus 3d will give you the a sub 4. Can you observe the pattern here? How is the indicated term related to the subscript here? How is the subscript here and the subscript here related to the numerical coefficient of your t? Okay, this 2, 1, and the common difference here is, the numerical coefficient of the common difference here is 1. You have the subscript 3 and 1, and you have 2 here as the numerical coefficient of t. You have 4 and 1, then comes 3 as your numerical coefficient of the t. So can you find a pattern that we can use as a formula? Okay, another example, 25, 23, 21, 19, and so on. You know that the common difference is negative 2. So that's 19 minus 21, 21 minus 23, 23 minus 25. What is a sub 3? So by looking at it, your a sub 3 is 21. You work backward, so a sub 3 is equal to a sub 2 plus d. And a sub 2 is represented as a sub 1 plus d. Therefore, a sub 3 is equal to a sub 1 plus 2d. Okay? We're going to solve for the a sub 4. So, we know that the a sub 4 here is 19. So, that came from your third term plus the common difference. So, that's 21 plus negative 2. But if you will work things out, a sub 3 is represented as the pattern observed here is a sub 1 plus 2 of the t. Then, a sub 4 is equal to a sub 1, then add this 3d's here, that's 3d. So, a sub 4 is equal to a sub 1 plus 3d. And by substitution, your a sub 1 is 25 plus 3, and the common difference, negative 2. Therefore, it's a sub 4 is equal to 19. Generally, if you will observe the pattern that we had, your a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Your a sub 1 is the first term, your d is the common difference, your n here is the position of the term here. This same subscript here is the n here. So every n in the formula represents the same number. Okay? So I said it already. You find everything. Okay. So generally, this is the formula in finding the n term of an arithmetic sequence. So we can look for a specific term without listing everything. Okay? So let's try to use the formula. Example 1. Find the 14th term of the arithmetic sequence. 4, 7, 10, 13, and so on. Some of you might think of listing them all till you reach the 14th term. That's fine with me. But in the long run, when you're given complicated problems, that will be difficult on your part. So for now, we will start with a simple example. So using the formula, a sub 14, these are the given first. A sub 14 is the unknown since you're looking for the 14th term. A sub 1 is 4, and your common difference, if you will solve for it, that's positive 3. The general formula for arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times d. By substitution, your a sub n is a sub 14. Your a sub 1 is 4, and the quantity 14 minus 1. 14 is the subscript here, and 1 is constant here. And your d is 3. Therefore, your a sub 14, without listing the entire sequence, is 43. Okay? You see? Next. Example number 2. Find the 14th term of the arithmetic sequence with the first term of 5 and the common difference is negative 6. The 14th term means, find the 14th term means you're looking for a sub 14. So in the formula, a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Your a sub n will be a sub 14. Your a sub 1 is 5 plus your n here is the same n that you will have here. So 14 minus 1 times your common difference as the given is negative 6. Then simply solve the equation. So this one, 14 minus 1 is 13. And then multiply this 2 using the PEMDAS. You have to multiply this first. So that's negative 78. So 7 plus, supposed to be with parentheses, negative 78 is negative 73. So your 14th term in the given sequence is negative 73. Easy, right? Example number 3. In an arithmetic sequence 4, 7, 10, 13, and so on, which term has a value of 301? Okay. Think about the given here. Your a sub 1 is 4. But you are asked here as which term has a value of 301. That means you're looking for the position of this 301 in this given sequence. So you're looking for n. And your a sub n is actually this one. You assume that this is your last term. So 301. And your common difference is 3. So by substitution from the general formula, your a sub n is 301. Your a sub 1 is 4. Your n is unknown because you're asking for the position. Minus 1 times your common difference of 3. Then, distribute 3 to every term in the quantity. So that's 3n minus 3. And then combine like terms. And 301 is equal to 1 plus 3n. And then use the addition property. So that is minus 1 to both sides. That's 300 is equal to 3n. Therefore, your n is 100. So it means that 301 is the 100th term in the sequence. Imagine that if you will list everything till you reach 301, you will be listing 100 terms before you get this 301. So this formula is very useful in most of the problems that you are asked to think of. Okay, next. Example number 4. In an arithmetic sequence, term 10 is 33 and term 22 is negative 3. What are the first 4 terms of the sequence? You have to think about it because you're only given a sub 10, which is 33, and a sub 22, which is negative 3. There are ways to solve this because you know that the general formula is this one, so you can plug in what are the available data that you have. So this a is actually a sub 1 plus 9d. So 33 is equal to a as the first term plus n minus 1. So that's 10 minus 1, so 9d. And the other side has negative 3 as your a sub 22, a sub 1 plus 22 minus 1 is 21 times your d. And you can use your concept on solving equations, system of linear equations. So, for the first one, so 33 is equal to a sub 1 plus 9d, negative 3 is equal to a sub 1 plus 21d. So, by elimination, you have 36 is equal to 12d and your d is equal to negative 3. So, I will use this equation, 33 is equal to a sub 1 plus 9d. You can also use this second equation, but I prefer to use this one. So, by substitution, I'll replace every d here with negative 3 as we solved from here. Therefore, negative 27 plus a sub 1 is equal to 33, and that gives us the first term as 60. Therefore, the first 4 terms of the given sequence are 60, 57, 54, and 51. Remember, in this kind of solution, you need the system of linear equation. So you have to create the first equation using the first given term that you have. So for this one, it's a sub 10. So just substitute in the formula. Then you use the given second term given. So by substitution, you have the second equation. And you do the elimination. Once you get the value of one variable, for this case, that is d, you can proceed with substitution to solve for the second unknown. For this case, it's a sub 1 or the first term. Okay? Quite difficult? Okay, let's try another solution. Okay, we will use the same problem, but this time we will solve the same problem, but this time we will use an easier solution. Okay, so again, we are solving for an arithmetic sequence. So always remember or memorize this formula. It will be helpful to you. Okay, so a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. We know that a sub n is the last term, a sub 1 is the first term, your n is the position of your last term, your 1 is constant, and your d is a common difference. But since the first term and the last term are both not given in the problem, we can assume one of this given is the first term and one of this is the last term. So I'll have a sub 22 as my last term, and a sub 10 is my first term. That is an assumption, meaning if you will move backward. Okay? Plus, your n here is 22. because that is the subscript here. Notice that this 1 came from the subscript here. It means if this subscript changes, then your 1 here will also change. So for this one, it will be 10 times your d. So a sub 22 by substitution, that's negative 3 is equal to 33 plus 22 minus 10 is 12 times d. So by addition property, negative 3 minus 33 is negative 36. So you have plus 12 on the other side and divide both sides by 12. Your d is negative 3. This is the same as the d that we solved earlier. Okay? Next, we need the first term. So to get the first term, we will still use the same formula. So either of these two will be the last term. I choose to have the a sub 10 as my last term. So a sub 10 is equal to a sub 1 plus 10 minus 1 times your d, which is negative 3. Your a sub 10 is 33. Your a sub 1 is unknown, plus 9 times negative 3. So by PEMDAS, 33 is equal to a sub 1 minus 27. Addition property of equality, so 33 plus 27 is 60. Therefore, the first term of the sequence is 60. And the first four terms of the given sequence are 60 minus 3, so that's 57, minus 3, that's 54, minus 3, that's 51. So this is the first four, these are the first four terms of the given sequence. Notice that if your common difference is negative, your sequence is decreasing. If your common difference is positive, your sequence is in increasing trend. Okay? Okay, so we'll have another example. So two terms of an arithmetic sequence are a sub 5, which is 10, and a sub 30, that is 110. What term is negative 2? So that means you're asked what position, in what position does negative 2 in or placed. So you can use the elimination method that we had. So you need to form two equations out of the given two terms. So if you will use the a sub 5, the equation by substitution to the general formula, you'll have 10 is equal to a sub 1 plus 4d. You have two unknowns, a sub 1 and d. And for a sub 30, you will be able to form 110 is equal to a sub 1 plus 29d, with the a sub 1 and d also as the unknown. So by elimination, you can solve for a sub 1 and d. So 10 is equal to a sub 1 plus 4d, and 110 is equal to a sub 1 plus 29d. So subtract that one and cancel a sub 1. So you will be left with your d equal to 4. And you can solve for the a sub 1 by substitution, and you will get negative 6. Then, since you're asked to give the to solve for the position of negative 2, then by substitution in the general formula, you will have your n as 2. Therefore, your negative 2 is in the second position, or that is the second term in the sequence. Let's try another solution. So we know that a sub 5 is equal to 10, and your a sub 30 is 110. Your a sub n as the last term is negative 2. We assume it to be the last term since we don't know the position of it. So n is unknown. We are solving an arithmetic sequence, so all we have to remember is this formula, and we can work things out from here. So a sub n, if I will place negative 2 here, I'll have the n being unknown, I'll have the a sub 1 being unknown, and the d as unknown. So that will be 3 unknowns in one equation. So we don't know yet how to solve that. So we will try to have just 2 unknowns, or if possible 1, because if it's 2 unknown, you will be going to elimination method. But if it's only 1, then you can solve it by simple equation. So I'll have the a sub 30 and a sub 5 placed as my last term and my first term. So that is a sub 30 is equal to a sub 5 plus, instead of n, that's 30, it came from here. Instead of 1, it will be 5, it came from the subscript here, times your d. And we have a value here, that's 110. 110 is equal to 10 plus 25d. And by addition property, 110 minus 10 is 100 and 25d. Then divide both sides by 25. Your d is 4, which is the same as the value of d in the first solution. But we are asked to solve for the position of this. So let's try to work from this equation, from this formula again. So this time I can use the negative 2 as my last term, since if I will place negative 2 as the last term, I don't have yet the first term, but I have the a sub 5 and a sub 30 to replace it. Then I'll have the d as 4. So I can do that. Negative 2 is equal to your a sub 1. Instead of a sub 1, I will use a sub 5 plus the n minus 1 times your d. So negative 2 as the last term, a sub 5 is 10 plus, we don't know the position, and this one will be 5 times 4. So negative 2 is equal to 10 plus, by distributive property, 4 times n is 4, and 4 times negative 5 is negative 20. Therefore, it's negative 2 is equal to 10 negative 20, that's negative 10 plus 4n. So 4n and negative 2 plus 10 is 8. Therefore, your n is equal to 2. It means that negative 2 is the second term. Okay? I hope that you got that correctly. For example number 6, we have two terms of an arithmetic sequence are the 8th term is 21, the 27th term is 97. Find a rule for the nth term. So the first solution that we have here is using the system of linear equation. You form two equations from the given two terms in the arithmetic sequence. So by substitution in the general formula. Once you are able to solve for a variable, for this example, we have solved for the value of d. So that is 4. You can use the value of your d to solve for your a sub 1. So for here, a sub 1 is negative 7. And simply substitute the a sub 1 and 4 as your d, for the d. A sub 1 as negative 7 and your d as to 4. So the general formula for this arithmetic sequence is negative 11 plus 4n. Another solution that you can use is the solution that we had earlier. So the assumption of the last term, okay? So two terms of an arithmetic sequence with a sub 8 is equal to 21 and a sub 27 is equal to 97. So let's find a rule. So let's assume that your last term, I'll write it so you can memorize it, okay? So a sub n, I'll have a sub 25 as my assumed last term, and I'll have my a sub 8 stand as the first term. Then the subscript 27 minus 8 times your common difference. So 26, a sub 27 is 97, a sub 8 is equal to 21 plus 27 minus 8 is 19b. So by addition property, 97 minus uh, 21 is 76. And that is 76 equals to 19d. Divide both sides by 19, your d is equal to 4. So we have the same value for the common difference. But this time, I will not solve for the a sub 1. I'll simply go directly to solving for the formula. So a sub n is equal to a sub 1 plus n minus 1 times d. I'll use last term, let's say, I'll have a sub n is equal to the a sub 8 instead of a sub 1 plus the n minus 8 times the d that we had. So that is solving for the a sub n is equal to your a sub 8 is 21 plus n minus 8 times your d, which is 4. So a sub n is equal to 21 plus, by distributive property, that's 4n minus 32. With this, we have a sub n. A sub n is equal to 4n. Negative 32 plus 21 is negative 11. So we have the same general formula of the sequence even without solving for the first term. Okay, is that clear? So that would be all for today. Thank you, stay safe, and God bless you.